Yes, is this my screen is visible?
Yes, sir.
Yeah. Okay, today we'll start module 2. Okay. Any idea what is module 2 deals with? Yes? Anybody has seen what is there in module 2? It deals with what?
The angle modulation.
Angle modulation. Good. Okay, so we'll start discussing about angle modulation. Yeah, anybody can say in what way this angle modulation is different from amplitude modulation? Yes, any idea? In what way angle modulation is different from just amplitude modulation? So we write carrier, right? Carrier C of t is equal to what AC, right? Cosine of 2 pi FCT plus pi, right? So in this, this one is what? Amplitude, right? And yes, this one is frequency, right? And this one we say phase, right? So in amplitude modulation, what we used to do is, anyone can say what we have done in amplitude modulation? Just quickly.
Vary the
So we were
amplitude.
varying the amplitude and frequency and phase were constant.
Now, can you repeat once again?
We were varying the amplitude, keeping frequency and phase constant
You are varying the amplitude of what?
of the carrier signal,
Yeah, in accordance with what?
message signal.
Yeah. So in case of amplitude modulation, we were varying the amplitude of the carrier signal, right? In accordance with the instantaneous value of the message signal, keeping frequency and phase constant. That is what is known as amplitude modulation, right? So this complete thing, 2 pi FCT plus phi, can be treated as angle, right? Okay, so you can treat this as angle. I can write it as theta I of t. Okay, theta I of t I can write. So to say angle modulation, okay, so there are two different types, what we can say, right? So here one is the frequency, another one is the phase, right? In angle modulation, we say there are two different types of modulation techniques. One is what? The phase modulation. One is the phase modulation. Okay, in short, we denote this as PM. Okay, another one is the frequency modulation. Another one is what? Frequency modulation. In short, we denote this as FM. Okay. Yes. So in case of phase modulation, right? So phase of the carrier signal is varied in accordance with the instantaneous value of the message signal. Okay. So phase of the carrier is modulated by message signal. That we call it as a phase modulation. Okay. So that is the definition of phase modulation, what we can say. Keeping other two parameters constant, that is amplitude and frequency. The second one is the frequency modulation we say, right? So here the frequency of the carrier, right, is modulated by the message signal. So that we call it as frequency modulation. So this is what the simple definition of phase modulation and frequency modulation. Okay. So class so let us say first one is what? Phase modulation. Phase modulation. What I said, in case of phase modulation, phase of carrier is modulated by message signal, right? So phase of carrier phase of carrier is modulated by what? Message signal. Right? Right here. Is this clear? Hello? In phase of the carrier, right? Phase of the carrier is modulated by what? The message signal. So let me write the unmodulated carrier.
Sir, in amplitude modulation,
Yeah.
we considered only C of t to be AC cos 2 pi of CT, right?
Yeah, that phi of t, we assume that it is 0.
0, okay.
Here I am splitting and saying what is frequency, what is phase, and what is amplitude also. Okay? Fine. So what I said in phase modulation, the phase of the carrier is modulated by the message signal. So let me consider the unmodulated carrier as just what AC, okay, cosine of 2 pi FCT. Okay. Okay, this is my what? This is my, I'm considering this is my unmodulated carrier. Okay. unmodulated carrier. Okay. So let me write I hope you have noted this definition of phase modulation. Everybody? Yes, have you noted?
Yes, sir.
Yes, sir.
No. Let me write the modulated phase. That is, can write that as what? Theta I of t. Okay. So theta I of t, which is equal to 2 pi fct plus, I can write it as kp m of t. Okay. So what is this one? Theta I of t is the modulated phase. Modulated phase. Okay. And this one is what? This one is my message signal, right? And you all know what is this Kp. Similar to in amplitude modulation, we used to write Ka is the what? Amplitude sensitivity factor, right? Similar to that, here we write Kp as the phase sensitivity factor, and it is constant. Okay. So Kp is what? Is the phase sensitivity factor, and it is constant, right? So here the modulated phase, right, theta I of t is proportional to what? Is proportional to the message signal, right? How the message signal is varying, no? Accordingly, the phase of the carrier will vary. So this is what the meaning of this. So theta I of t is equal to, I said 2 pi fct plus kp into m of t, right? So now I can write the modulated signal as that is phase modulated signal. Okay, modulated signal is so S of t is equal to say AC cos of, right, theta I of t. Okay. So now let me substitute the value of theta I of t in this equation. So that becomes the phase modulated signal. So what we can write? AC cos of, what is theta I of t? It is 2 pi fct plus kp into m of t. Okay. So this is the expression for phase modulated signal. Okay. So this is what I can say phase modulated signal. Fine. Yes, is it fine or do you have any doubts in this? So I took the unmodulated carrier is this AC cosine of 2 pi FCT, right? So I'm writing the modulated phase as what the phase of the carrier signal is proportional to what? The message signal, right? Means the phase of the carrier is modulated by the message signal. So I can write like this, theta E of t is equal to 2 pi FCT plus Kp into M of t. I said, what is this Kp? Kp is the phase sensitivity factor, so which is similar to Ka in the amplitude modulation. What we used to say, it is an amplitude sensitivity factor, right? And which is constant. So I said the modulated signal can be written as what? S of t is equal to AC cosine of theta E of t. Just I am substituting the value of theta E of t in this equation. I can say this is the expression for phase modulated signal, okay, which is equal to what? AC cosine of 2 pi FCT plus Kp into M of t. Yes, have you noted this?
Yes, sir.
Shall I scroll up?
Yes, sir.
So similar to this, let me write the expression for FM signal. That is the second one, I can say. Frequency modulation.
Sir,
Yeah,
can you scroll on top, sir?
on top, yes. Yes, where?
So here, sir, theta I of t.
Ah,
So what is Kp in that, sir?
I said that is a constant, that like similar to standard AM, what we used to write Ka, there is amplitude sensitivity factor.
Okay.
Similar to that, here we say it is a phase sensitivity factor.
Okay, sir.
Okay, so how does the value of Ka affects the modulation? So similar to that here, so it is a proportionality constant, what we can say, Kp, right? Because the proportionality constant is replaced by this number, Kp. So the phase of the carrier will be varied depending upon how the message signal varies. Yeah. Is that fine?
Yes, sir.
Yeah. Okay, in case of frequency modulation, so what do we say? The instantaneous frequency of the carrier, right, is modulated by the message signal. So we can write the definition of frequency modulation as what? Means the frequency of the carrier, right, will be varied in accordance with the value of the message signal, right? So we can write it as okay, instantaneous frequency of carrier is modulated is modulated by the message signal. So similar to the modulated phase, what we have written in the phase modulation, we can write what is the modulated frequency. Okay, so that I denote it as Fi of t. This is the what? Instantaneous frequency, Fi of t, okay, which is equal to, okay. So what we can write? Fi of t, similar to the PM, what we have written. So your unmodulated carrier frequency, which is Fc plus Kf into m of t. Okay, so this one is known as the instantaneous frequency or the modulated frequency. Modulated frequency. So this is the unmodulated frequency, right? Fc, that's a carrier, and that will be varied accordingly the message signal, right? So that is known as the modulated frequency. So modulated frequency varies from unmodulated carrier frequency with respect to the message signal. Again, here is Kf is the what? We say that as frequency sensitivity factor. Similar to the PM, what we said it is Kp, here we say it is Kf. Okay? So that proportionality factor is replaced by this number, that is Kf. Is this fine? This is the unmodulated carrier, and that will be varied according to the message signal. So that is what we say is the modulated frequency, Fi of t. Yeah, how phase and frequency are related? How frequency and phase are related? This is a very basic relation you are supposed to tell. How velocity and acceleration are related, you are all aware, no? Yes, anyone can say how velocity and acceleration are related? Yes, what you can't say how velocity and acceleration are related.
Sir, if you differentiate
Ah.
velocity, you'll get acceleration.
Then, so that is a basic thing, right? So similar to that here, what is frequency? Rate of change of phase, right? So I can write the phase of the frequency modulated signal as phase of frequency modulated signal right? Phase of frequency modulated signal will be written as, let me say this is the phase theta I of t, right? So which is equal to 2 pi integral 0 to t. Okay? I can say instantaneous frequency Fi of tau into t tau. Right? So because what I can write is here the instantaneous frequency, okay, Fi of t is defined as 1 by 2 pi, okay, into d by dt of theta I of t. d by dt of theta I of t. Okay, so from this we can say what is theta I f, right? Yes or no? So with respect to that, I have written here, you can write theta I of t is equal to what? 2 pi at integral 0 to t fi of tau into d tau, right? Yeah. So you can keep these equations as basic equations. So from this I wrote here theta I of t, that is phase of the frequency modulated signal, as what theta I of t is equal to 2 pi integral 0 to t fi of tau into d tau. So now let me substitute the value of fi of t in this equation. And let me say what is theta I of t. So theta I of t is equal to what we can write? 2 pi, right? Integral 0 to t. Okay. So it is what? Fc plus kf say m of tau, m of tau into theta. Okay. So just do the simplification. What we can write? Is what we can write theta I of t as theta I of t is equal to, is what is the first term? 2 pi fct, right, plus 2 pi kf, right, then integral 0 to t m of tau into d tau. So this is the what? The phase of the frequency modulated signal. This is the phase of frequency modulated signal. So now let us write the expression for frequency modulated signal, that is S of t. Yes, what is the expression for frequency modulated signal we can write? Is what we can write, S of t is equal to AC, right, into cos of theta I of t. Isn't it? Just substitute the value of theta I of t in this equation from this. So which is equal to, we can write it as AC right? Cosine of 2 pi FCT plus 2 pi kf and integral 0 to t m of tau into theta. So this is the expression for FM, that is frequency modulated signal. As you can say, this is the FM signal. Yes, any questions with respect to this? Whatever I have written for frequency modulated signal. Yes, do you have any questions? Yes, is it clear? I am asking. What I started with? I started with the definition of FM. What I said? The instantaneous frequency of the carrier is modulated by the message signal, right? So how do I represent that? The modulated frequency as what? The carrier frequency, this is unmodulated carrier frequency, plus kf into m of t, right? Means, see, the modulated frequency varies with respect to what? From the unmodulated carrier value to with respect to what? The message signal, right? So that proportionality factor, I am representing it by kf. I said kf is the frequency sensitivity. Okay. Then I found what is the phase of the frequency modulated signal. So how do I establish the relation for that? I know what is the instantaneous frequency, right? Which is equal to 1 by 2 pi d by dt of theta a of t. So from this I can find out what is theta a of t. So which is equal to what? 2 pi into integral 0 to t fi of tau into dt d tau I can write, right? So I use that formula here. So phase of the frequency modulated signal will be equal to what? Theta I of t. So which is equal to 2 pi integral 0 to t fi of tau into d tau. Right? Just I substitute the value of fi of t in this equation. Then I expanded that and I wrote what is the value of theta I of t. And then I am substituting the value of theta I of t in the standard expression for modulated signal. That is S of t is equal to AC cosine of theta I of t. Right? So I say this is the expression for the frequency modulated signal. AC cosine of 2 pi FCT plus 2 pi KF integral 0 to t m of tau into d tau. Yes, is this clear? Shall I go to the next one? Yes, I am asking you people only. Is this clear or do you have any doubts in reading any of the equations? Huh? What questions? Yes, what Prithvi?
No doubt, sir.
No doubt. Then shall I proceed further? Okay, what is the difference you are finding in the expressions of PM and FM? Yes, Prajwal, can you say, looking at the expressions of PM and FM, what difference you are finding?
Sir, in PM signal, the apart from the AC, meaning leaving amplitude, the theta I of t is there. No, FM signal, it is integration of that.
Yeah, in case of PM, so S of t is equal to AC cosine of 2 pi FCT plus Kp into M of t, right?
In FM, it is the integration of theta I of t.
Yeah, it is the integration of M
Theta
of
I of t of S of in this thing, sir. PM.
yes. See, this is the expression for PM. What is it is AC cosine of 2 pi FCT plus Kp into M of t. See, the first part is same, AC cosine of 2 pi FCT, right? Here the second part is what? It is proportional to M of t, right? So here the modulated signal in case of FM, right? It is proportional to the what? Integral of the message signal, right? So what we are finding here in the expression of FM, right? The modulated signal is proportional to what? Integral of the message signal. Okay, so let us try to understand in what way this PM and FM are related. Okay, is it possible to say clearly what is the difference between FM and PM? So before that, so let us try to understand what is this frequency deviation and as well as the phase deviation. Okay. So the frequency deviation means what? What can we say about frequency deviation? Means what is the maximum change in the frequency of the carrier signal from its unmodulated value is known as the frequency deviation. I hope you understand, na? The maximum change in the frequency of the unmodulated carrier, okay, from its means what is the change in the frequency of the modulated signal, okay, from its unmodulated carrier value. So that is the frequency deviation. So what I can write is, I can write for the deviation, okay, the maximum frequency deviation, how much it can happen is, okay, see maximum frequency deviation means how much it is varying from its unmodulated value. What is the change in the frequency of the unmodulated carrier? Okay, that will be the value of frequency deviation. Okay, so which is equal to, I can write it as maximum. I'm saying maximum frequency deviation, right? So from its, it is Fi of t is the what? Modulated frequency, right? Minus Fc. Yes, is this clear? Fi of t is the modulated frequency, right? And Fc is the unmodulated carrier frequency. So how much the difference is, that will be the deviation, frequency deviation. Okay, just substitute the value of Fi of t here. So what is Fi of t? It is Fc, right, plus Kf to M of t, then minus Fc. So minus Fc plus Fc will get cancelled. So we will be getting as what? The maximum frequency deviation as Kf into M of t. Okay, and we can take this Kf outside. And we can write it as KF into maximum value of M of t. Okay, so we can denote this frequency deviation by delta F. Delta F. So what is this? I said is the maximum frequency deviation, or it is also known as peak frequency deviation. Peak frequency deviation. Okay. So what delta F will give? It will give you the change in the frequency of the modulated signal, right? So we can say how much change is happened from its unmodulated value. Okay, so which is proportional to what? AF into the maximum, okay, signal amplitude of the message signal. That is what the meaning of this is. Delta F is equal to KF into maximum value of M of t. Okay, now let us consider with respect to the sinusoidal message signal. Now I have written in general. I have not told what is M of t, whether it is sinusoidal signal or something else. So now let us try to find out the expression for PM and as well as FM with respect to sinusoidal modulation. That is, sinusoidal modulation means we need to consider the message signal as a sinusoidal signal. Okay. So the example. Let us consider an example of what? Sinusoidal modulation. So let us begin first with the phase modulation only. Okay, since we have discussed phase modulation first. So phase modulation. Okay. So now let me write M of t. Let M of t will be equal to AM into sine of 2 pi FMT. Is this fine? So A suffix M is the what? Amplitude of the message signal, and FM is the frequency of the message signal. Right? Yes. Is this fine? Yes, I am asking you people, is this fine? Considering M of t as AM sine of 2 pi FMT.
Yes, sir.
Yeah. So now I started with phase modulation. No? So let me write the expression for the modulated phase. What is the expression I have written for modulated phase? Yes, anyone can say modulated phase. What is modulated phase? That is, yes, Manoj, can you say what is the modulated phase? Manoj?
Yes, sir.
Yeah, what is the modulated phase? Man, how can I write the modulated phase? modulated phase, that is theta I of t. Yes, what is the expression I have written? Yes, what is theta I of t?
2 pi fct plus kp m of t.
Yeah. So theta I of t will be equal to what? 2 pi fct plus what?
kp m of t.
M of t. Right? So now just substitute the value of m of t as what? Am sine of 2 pi fmt in this equation. Okay. So which is equal to what? Yes, Manjunath.
Sir,
Yeah, can you just say what is the equation? The substitution of in this.
sir, Kp into
Yeah,
Am
yeah, Am
sine 2 pi
sine of,
FMT.
yeah, sine of 2 pi
FMT.
fmt. Fine. So this is my theta I of t, right? So now what is the expression for the phase modulated signal? Yes, Ananta, can you say? Ananta?
Yes, sir.
Yeah, can you say what is the phase modulated signal I can write? Yes, phase modulated signal, that is S of t. What is the expression, man? AC, right? Cos of theta I of t. Why this is not written? Why you have not noted this equation in your notebook? So now can you substitute the value of theta I of t and say what is the expression for phase modulated signal when we consider m of t is a sinusoidal signal? Yes, Ananta.
Yes, sir.
Yeah, can you just say?
S of t equals AC
Yeah, AC.
into cos of
Yeah.
FCT,
Theta I of t. Yes.
2 pi FCT.
Yeah. Yeah, tell me. AC cosine of
Cos of 2 pi FCT plus
yeah. I hope you understand why I scroll down. Yeah, it is AC cos of
2 pi FCT
yeah 2 pi FCT plus
KP
yeah KP
AM
AM
sine of 2 pi FM.
sine of 2 pi FMT, right?
Yes, sir.
So this is what the expression for phase modulated signal when we consider the message signal is a sinusoidal signal. I hope is this clear? Yes. So if
Yes, sir.
you write the suffix as PM, S PM of t, this is a phase modulated signal when you consider the message signal is a sinusoidal signal. Okay. So now let us try to find out what is the instantaneous frequency, right, for this. So what is the expression for instantaneous frequency? Fi of t.
FC plus KFM of T.
No, let us go with the basic definition Fi of t. That is what? 1 by
by d by dt.
yeah, 2 pi d by dt of
Theta I of T.
theta I of t. It does not skip any step. So now what we are supposed to do? The value of theta I of t and write it. What is Fi of t? So Girish, can you say? Just substitute the value. At least you tell the substitution part. D by Girish. Yes, is there?
Yes, sir.
Yeah, tell me. What is you have to tell what is the value of theta I of t for this? So what is the value of theta I of t?
2 pi FCT.
2 pi fct plus
KP M of T.
you have to tell the value of m of t, man, here.
KP
Uh,
AM sin 2 pi M of
what? 2 pi?
FMT, sir.
2 pi fmt.
Yes, sir.
Okay. Yeah. So yes, Gautam Hegde.
Sir.
Gautam Hegde. Just yeah, can you say what is the differentiation of this one? What is the first part? What I can write?
By 2 pi.
Yeah, 1 by 2 pi. See, d by dt of 2 pi fct. What you will get, man? The 2 pi will get cancelled, no? So you will be getting what? It is just fc only. Yes or no?
Yes, sir.
Yeah. Then next is what? Next is, yeah, you should tell. 1 by 2 pi, okay, just I'm multiplying with 1 by 2 pi, okay, into what you can write kp, right? Then am, yeah, now you tell me what I should write. What is the differentiation of sine of 2 pi fmt? Yes, quickly, already.
Cos
Yeah, what cos? You should tell clearly.
2 pi FM.
Yeah, cos 2 pi fmt, that's all. Or something is left out.
Into 2 pi FM.
Into 2 pi fm, right? So I can write it as 2 pi fm into cosine of 2 pi fmt. Okay? Is this fine? So now what I can do, I can cancel this 2 by 2 pi, right? So I can rewrite it as Fi of t is equal to what I can write? Yes, Tipana, what do you say? Tipana.
Yes, sir.
Yeah, can you say
FC,
what I can write? Yeah, it will be
FC plus
yeah, Fi of t will be equal to Fc plus
cos 2 pi f 2 pi f
yeah, Kp
am
Am into Fm, right? Fm, then cos of 2 pi fmt. Okay, so this is the expression for the instantaneous frequency. Isn't it? So this is the expression for instantaneous frequency. Yeah. So now Let us find out what is the maximum frequency deviation.
Sir, lunch, sir.
Yeah. 2 minutes. I will complete this with this, sir, and I will close.
Sir, time up, sir. We have to go.
Man, just 2 minutes I'm saying now. If you are able to bear, I will continue 2 minutes. Otherwise, I will not. What is your conclusion? Because you people are joined 10 minutes late. Still, I need to bear that, right? Yeah, quickly, I think who is talking now? Time up. That's what I only can say, na? What is the maximum frequency deviation? Yes, quickly. See, it all depends on how fast you say. That much fast I can finish up. Yes, quickly. From your side, I expect maximum frequency.
Sir, it's maximum of Fi of t minus Fc.
Yeah. When right, maximum frequency, right, deviation, maximum frequency deviation. What is the definition of delta F? Is equal to, right, maximum of what? The instantaneous frequency T minus the unmodulated carrier frequency, right? So now you know what is the value of Fi of t and Fc, right? So what do we get here? So that minus Fc plus Fc will get cancelled.
सतीश से करवा रहे हैं ना कैजुअली में करवा के दे दो
Yes, what I get, right?
5 मिनट में हो जा ऐसे कैसे खत्म कर जाएंगे इससे
Yes, who is that fellow should mute. Somebody is talking, right?
बनवा के ले आएंगे फिर क्या
Mute man, mute.
मम्मी उसकी उम्मीद भी एड्रेस प्रूफ चाहिए आपको कहां से दोगे
Mute now. Yeah, see, minus Fc plus Fc will get cancelled. What is left out?
Fm, meaning it'll Fm, Kp, Am, cos 2 pi Fm of t.
Yes, Kp, Am, Fm, right, into cosine of 2 pi Fmt, right? So you know the maximum value of cos is 1, right? So during that time, what I get? What is left out? When cos
Kp, Am,
is
Fm.
1, so I get delta F as what? Kp, Am into Fm as the maximum frequency deviation. Okay. So let me stop with this. We'll discuss further tomorrow. Okay, next class.
Sir, can you scroll on top, sir? Just a second.
That's fine. Yeah, where, man?
Little more, sir. Yeah, enough.
So I wrote the expression for Fm of t. Then from that I am writing what is the, I am finding what is the instantaneous frequency. After finding the instantaneous frequency, I am finding what is the maximum frequency deviation. Yes, is this fine?
Yes, sir.
Yes, sir.
Yeah. Quickly, you people should answer your attendance. Okay. Aditi. Akshay.
Yes, sir.
Anand. Anand. Ananta.
Yes, sir.
Ashwini.
Present, sir.
Sujan.
Yes, sir.
Bharti. Chandan.
Present, sir.
Chandana.
Present, sir.
Chandrika.
Yes, sir.
Ram. Sai. Danya.
Present, sir.
Girish.
Yes, sir.
Ima.
Yes, sir.
Yes, sir.
Skanda. Bhargav?
Yes, sir.
Arunya?
Yes, sir.
Kuber?
Yes, sir.
Leah?
Yes, sir.
Manasa?
Present, sir.
Manasa is it?
Present, sir.
Really? Manjunath?
Yes, sir.
Manoj?
Yes, sir.
Manusri?
Present, sir.
Mohammed?
Present, sir.
Mohan Sai? Namita?
Present, sir.
Noreen?
Present, sir.
Venus?
Present, sir.
Niharika?
Present, sir.
Nishchit Jain?
Present, sir.
Pooja?
Present, sir.
Rajwal?
Present, sir.
Sri?
Present, sir.
Present, sir.
Rakshita K?
Present, sir.
Ramya?
Present, sir.
Rishabh?
Yes, sir.
Yes, sir.
Prashant?
Present, sir.
Gayatri? Arshita?
Present, sir.
Sachin? Sanket?
Present, sir.
Suresh?
Present, sir.
Siddharth?
Yes, sir.
Suvigraj?
Yes, sir.
Sudiksha?
Present, sir.
Kana?
Yes, sir.
Present, sir.
Madhva?
Yes, sir.
Danish?
Yes, sir.
Abhishek?
Present, sir.
Gautam?
Yes, sir.
Raghaveni?
So,
Yes, sir.
19 present, sir. Just checking.
What man?
So 19 present.
Fine. Saga.
Okay.
So 54 present, sir.
Okay, man.